Welcome to part 2 of The Beginner's Guide to Scale Modeling. Hi everyone, I'm Rod. This is Red Leaf Scale Modeling, and we're going to start this segment with a correction. If you watched part 1, you'll remember that by the end of the video, we came up with our own strategy for the execution of the project, and step 1 was the assembly of the wings. In fact, step 1 was discussed when we were looking at the drawings, and it was decided to bring all of those detail parts at the back end of the project to the front end of the project to improve our overall workflow. So this segment is going to be all about the different thought processes and techniques that we're going to use first to prepare our parts to accept a coat of paint, and second to get them ready for assembly. So with that, grab your favorite bevy, turn on the game, and let's get to work. Sometimes we want to build sub-assemblies and then paint them, like with the wings. Other times we want to pre-paint a bunch of parts and then create a sub-assembly, like with the cockpit. So the next thing we're going to do is clean up all of our parts and get them ready for both painting and assembly. So the first thing we're going to do is take a look at the techniques to clean up all of our parts and get them ready to accept a coat of paint. Paint highlights details, both good and bad. So when we're cleaning up our parts to get the best paint finish, we want to enhance the good detail and eliminate the bad details. In other words, we want to remove all of the visible flaws from the surface of the parts. The part should be pristine by the time we're done. The better the surface finish, the better our chances of getting a good paint finish. Now the good details include things like panel lines, or in this case, the fairings on both the tail and the fuselage. And the easiest way to dress them up is by using a large pin and just very gently dragging it either through the panel lines or along the edges of the fairings. The bad details, though, include things like ejector pin marks, both raised and recessed, mold seams, flash, which really is just a bad mold seam, and sink marks. Now the ejector pin marks, mold seams, and flash are easy to see with the naked eye, but sink marks are not. And the easiest way to see them is by using the same technique that causes your heart to drop when you see them on your beautifully finished model, and that is with reflected light. Now the other thing is that mold seams are not random, and the easiest way to know where to look for them is by finding detail on the inside of a part. As the plastic cools and shrinks, it sinks down into the deeper part of the detail, and it leaves a sink mark on the surface of the part. And we can see on the wing, the interior detail is perfectly telegraphed by the sink mark on the upper surface of the wing. As soon as we took the first parts off the sprues, in addition to relabeling them, we also took a quick look at each part, figured out what work needed to be done to clean them up and get them ready for paint, and then organized them accordingly. Now thankfully, there were no parts that needed to be repaired, but there were some that needed some ejector pin marks and sink marks filled, and then the bulk of them simply require the basic cleanup for mold seams. So we're going to start by putting the putty into the sink marks and ejector pin marks, and then while we wait for the putty to cure, we're going to turn our attention to cleaning up the mold seams on the balance of the parts. To me, a putty can be applied directly from the tube, either with a toothpick or a small brush. But for ejector pin marks, I prefer to thin it slightly with Tamiya's lacquer thinner and apply it with a very small paintbrush. With careful application, the surface tension of the putty does the bulk of the work for us, and the result is a near perfect finish that requires very little cleanup. To fill the sink marks, we thin the putty to a paintable consistency and then carefully apply a very thin layer into each of the sink marks. When this is dry, we'll sand and polish these areas using progressively finer sanding sticks from 600 to 2000 grit, which makes it very easy to see where and if we need to apply any more putty. Now we repeat this as often as we need to, 2 or maybe 3 times at the most. But once we're satisfied that we don't need to apply any more putty, we'll carry the polishing up into 4000 grit, which is very important because we want to make sure that the surface finish on the area that we've been working on matches the original factory finish as closely as possible. As a final step in this area, we can open up any of the clogged panel lines by using a large pin, and once this is done, if there's any sharp edges or burrs that need to be dealt with, a quick swipe with some Tamiya Extra Thin cleans everything up. Okay, so while the putty's curing in those ejector pin marks, we're going to start cleaning up the other parts. And the tool that we're going to lean on is going to be the hobby knife with the number 11 blade, which can do a more than satisfactory job of all of the cleanup tasks we need to do. But to make some tasks easier, we're going to add a few extra tools like some sanding sticks from 320 to 4000 grit, a set of needle files, a 6-inch flat mill file, a set of large pins, a razor saw, and a micro drill bit set. Mold seams are a natural part of the injection molding process, but they need to be removed wherever they create an unnatural feature on the model. And with this blade, we can get them all. The smallest, the largest, the most complicated, even the clear parts. The goal is to remove the mold seam or join line without altering the design shape of the part. And in my experience, one of the best and easiest ways to do that is by sweeping the blade across the mold seam at an angle. And this technique works equally well on rounded shapes, radiused edges, squared edges, and compound curves. Now, as we get started, we're going to tackle the tedious or the difficult tasks first, and we're going to brace our hands and fingers for all fine detail work during cleanup, assembly, and painting. Having said that, we're going to start by cleaning up the second to smallest part in the kit, and the number 11 blade is definitely my tool of choice for any delicate parts of this type, either round or square section. Lock your wrists against the bench, lock your fingers together, and grip the handle as close to the blade as possible, which gives us maximum control over the movement of the blade. We want to very gently sweep across the mold seam at opposite directions, and within 10 minutes, we've reestablished the design shape of the part and achieved a very respectable finish. The tail wheel assembly is compact and busy, but cleanup with the knife is easy. It's the one tool that can get into the tiniest spots and polish the surface as it actually removes the mold seams. Now in this situation, to work across the mold seam from both sides, it's actually more efficient to simply roll the part over my fingers than it was to flip the part end for end. To clean up the steps, we can sometimes position the honed edge of the blade against the mold seam at the base of the step, and then gently rotate the tool backwards to work the blade up and along the mold seam. Other times, a gentle flick with the tip of the blade may be all that's necessary. And without any additional sanding or polishing, the result is more than satisfactory. So we just need to be patient and follow the process. Sweep across the mold seam at an angle, move out on the blade to cut, move to the tip to polish. Oppose the direction of the passes of the blade to knock down the high spots and maintain the design shape of the part. The mold seam along the center line of the tire is a simple curve and benefits from exactly the same procedure. To knock down any dust or burrs, a couple of quick passes with some ultra-thin cement will clear everything up, and in about 20 minutes we have a beautiful looking part. Cleanup of the main landing gear strut gives us a perfect demonstration of the overall effectiveness of the number 11 blade as our principal cleanup tool, but it also sets the stage for all of the other cleanup work that we have yet to do. Now the larger parts mean the work is a little bit easier, but it also comes with some larger gates, a raised ejector pin mark, mold seams inside and outside the torque arms and along the piston, compound curves along the arm at the bottom of the strut, some flash on the axle, and a very tight space between what is supposed to be the bracket for the strut cover and the upper collar for the torque arm. We'll start by shaving off the residual gate material and immediately dress the area. And because it's located on a mold seam, we'll also clean up the entire length of that mold seam. We'll treat the raised ejector pin mark exactly the same way. Using that as our starting point, we're going to follow that mold seam all the way down around the bottom of the strut and back up the other side. We'll use our basic technique on the flat sides of the strut cover mounting bracket, and then we move down into the piston area. Now we jump over to the far side to clean up the mold seam on the outside of the torque arms and the strut cover mounting bracket. But it's this narrow gap between the strut cover mounting bracket and the upper collar for the torque arms where we reverse our blade and use the square edges on the back side of the tip of the blade as an extremely effective seam scraper in this extremely narrow gap. Once we're done, a quick swipe with some ultra-thin cement cleans up any dust or burrs. Carefully remove the flash on the tip of the axle. Carefully clean up the compound curves each side of the arm at the bottom of the strut. Work on the piston and the inside of the torque arms. And then finish with some easy mold seam removal on the entire upper end of the main cylinder. And in about 20 to 30 minutes, with no additional polishing or sanding, we have a very respectable result. Now these techniques work equally well as the parts get larger because we naturally use more or less of the blade depending on how much room we have to work in. But it's especially well suited for use on compound curves, and this particular model is loaded with them. We use our slice and twist technique to clean up some significant mold seams at the base of each of the propeller blades where the cuff meets the shank. Then we use long sweeping passes with the blade to clean up the compound curves around the perimeter of each of the paddles. In my opinion, this is the best tool for this task. Easily transitioning between different shapes and sizes, heavy work to the gentlest work. But referring specifically to the work that we do along the edges of the paddles, we're able to remove the mold seam, establish the design shape of the part, create a very smooth edge by removing any sawtooth, and polish the work area as we go. And this all happens very quickly. The tailplane is a simple wafer design, with a mold seam around the entire perimeter of the part. But the feature we're interested in here are the two compound curves on outside corners at the tip. In this case, our method is as important as our technique. So the first thing we're going to do is dress the leading edge, the tip, and the trailing edge, and establish all three of those profiles. This is going to set the start and end points for the corners. Then we fall back and blend the corners into the adjacent profiles. And within 10 minutes, here's what we've got. This technique works equally well on square profiles, and to demonstrate that, we're going to clean up the lip that runs around the outside edge of the main gear door. Now at a glance, the part looks perfect, but every part coming out of a two-part mold has a mold seam, and we can see it run through the sprue and then drop down and run right along the inside edge on the lip of this door. But there's something else going on here. If we look very closely, we can see that the outside edge on the lip of the door is actually got a very subtle angle when it's actually supposed to be square, and that is draft. Draft is a very subtle angle designed into the sidewall of the molds to help certain parts release more easily. Now, it's not a major concern, but it is supposed to be square, so we're going to square it up and remove the mold seam at the same time. Okay, now I'm going to use this drawing and a couple of props to explain what is going to happen and hopefully make the next segment of video a little bit easier to understand. Now we're going to start from the outside face and work towards the inside face. Here's our draft angle here, and our mold seam forms right here. Now we're going to use this angle up here as our benchmark on the outside face. That is the good edge. And what we want to do is square up this face. So we want to remove all of this material out here. Now what we're going to do is we're going to hold our blade perpendicular to this face, or parallel to the edge that we still have yet to make, if that makes any sense. Now we're not going to hold the blade at a rigid angle, and here's my props. What we're going to do is we're going to bring the blade in. It will be perpendicular, right? So we want to cut the face perpendicular this way. But what we're going to do is we're going to rotate the blade out so that we're working at a very shallow angle, and we're going to rotate it over so that we're just sweeping that edge very gently. And we're going to work from the bottom edge down here parallel to this face that we're going to make, and we're going to work across this way in gentle passes, right, removing the material like so. Now by the time we get into this corner here, remember the reflectivity of these surfaces is going to be different as we cut this. So as this material is being cut away, there's going to be a shiny spot here at this corner, or along any of the material that we haven't cut yet. So we sweep along this edge, and eventually we get to a point at this corner where this entire face is the same reflectivity, and we keep checking to make sure that we're actually perpendicular so that we've actually got a square face, all right? The second thing we're gonna do is roll it over now to this bottom edge, right? So we want the bottom edge down here because the material is gonna build up down here at the bottom. We roll it over, and then we need to run the blade. We're gonna run our blade along this edge and just very carefully with the tip, like so, we want to set the blade parallel to this face. And then very carefully run the blade down along that edge. So again, we're running it at a bit of an angle this way and flat against that surface, and then just very carefully shave off that material. Once that is done, number 3 is we're going to come up from the bottom now. So we just rotate this onto its edge and then make another glancing pass with our blade. And we just very carefully sweep that edge, and now we're removing this material here. We're removing this material here. We very gently sweep this edge, and we'll see the mold seam come right off on the back side of our blade. So here's what it looks like on the actual part. Sweep the blade from the outside face towards the inside face to square up the edge of the lip. And we can see the material build up along the inside edge of the lip. Roll the part over, sweep the tip of the blade down the length of the part to clean off the edge, and then sweep the blade from inside towards the outside to clean up the waste material. It's quick, it's easy, we clean up the part within a couple of minutes, and we have a nice square edge. We always want to practice any new technique before using it on our models. And the easiest way to get some practice with these techniques is by using different parts of the sprue. So we'll cut out a few representative shapes, mark them with some ink, and practice our technique. We'll cut out a simple curve, compound curve on an outside corner, compound curve on an inside corner. We've got the raised ejector pin mark here. We've got a flat surface on top of that raised ejector pin mark. And then we've got our square edge. These techniques are all about feel, but they're very intuitive, and you'll pick them up very quickly. Believe me, it's a few minutes very well spent. To clean up the tread pattern on the tires, we're going to start by removing most, but not all, of the mold seam using our blade. We want to be careful not to create a flat spot on the ground contact surface of the tire. Once this is done, we're going to break out the razor saw, and we're going to very carefully open up the grooves across the mold seam. Once we've got this done, we're going to establish the profile of the tire using first our knife and then a 600 grit sanding stick. After that, we can touch up any of the grooves very carefully with our razor saw, and in about 20 to 25 minutes, if there's any excess dust or burrs, we clean the whole thing up with a little bit of ultra thin cement, and we're done. Obviously, we need to open up the exhaust pipes, so this will be our first modification to the kit parts. Now, the process may be a little tedious, but it's actually quite simple, and the results are so gratifying. The actual pipes have a weld seam running down the center line of each of the pipes, so the only mold seams we need to remove are going to be those on the collar and the face of each pipe that we intend to drill out. So our goal here is to make sure that our pipes are actually round. We start the process by punching the center of each of the pipe openings with a pin. Then, we very carefully, by hand, drill a small pilot hole at each of the centers, about 1 millimeter deep, which is important for delicate parts like these because it keeps the larger bit centered, but it also provides relief for waste material so that the larger bit doesn't burst the sidewall of the pipe. Then we'll drill out each of the pipes with a bit that's about 3/4 the size of the actual diameter of the pipe. And you'll notice the repeated back and forth rotation of the bit, which is necessary to keep these bits from cutting too quickly. These are PCB bits, or printed circuit board bits, and they're designed to cut heat-sensitive material very quickly. So the trick is to actually pull back on the bit to control both the depth and speed of the cut. Once everything is drilled, we'll go back to our number 11 blade to clean up center and sidewall thickness, and clean up any burrs with some ultra thin cement. And in about 20 minutes, we've got a beautiful looking set of pipes. And we use this same approach to open up the intakes along the fuselage. clean up the canopy, we're going to use the same basic tools and techniques, but we're going to add some masking tape and a little extra TLC. Carefully remove it from the sprue, prep some masking tape, and then mask both sides of the canopy tight to the gates. Carefully pare away the gate remnants from both sides of the canopy and the bottom edges. Dress the bottom edges of the canopy with sanding sticks, once again using reflected light to gauge both progress and quality. Then dress the sides. Remove the masking and complete one final quality check. The gun sight has been molded clear, which is a great place to start, but we've got a serious mold seam that needs to be removed to improve both the clarity and the fitment within the instrument panel. So we get comfortable and employ all of our best blade techniques to dress this part as well as we can. And in about 20 minutes, we get a respectable looking part that's still a bit cloudy. So to clear that up, we're going to dip it in Tamiya's X35 semi-gloss clear. And it's important to mix the clear by swirling it, which avoids the creation of microbubbles. Now we just grip it and dip it, but the clear is thick, so we want to dip the part very slowly to avoid trapping any air bubbles, and then we want to withdraw very slowly to allow the surface tension to pull off any excess material. Carefully blot off any excess material on a paper towel. Place it under cover to dry dust-free, and in about 25 minutes, you've got your very first experience with dipped parts. Now let's circle back and clean up those ejector pin marks, and to do that, we're going to reach for the lacquer again, so make sure you've got good ventilation. Now we've already seen that we can thin this putty with lacquer to control its placement, but what's equally useful is the fact that we can use the lacquer to wake it up again once it's fully cured, which is especially useful in very hard to reach areas like these. So we load our brush with lacquer, wet the area, and very gently sweep across the top of the putty until it starts to wake up. Now the key to this whole process is the rapid evaporation of the lacquer. We need to keep the area wet so we can flatten out the putty over the ejector pin mark and basically create a puddle of self-leveling putty. But because the lacquer evaporates so quickly, we need to keep adding lacquer to the puddle. As soon as we see that we have a flat area over the ejector pin mark, we simply stop adding lacquer and allow everything to start tightening up again. At this point, we clean the brush, and now when we come back in, we use it to clean up any excess putty. And after a total of 20 minutes, here's the result. Of course, we can always make our own micro tools with small swatches of abrasives superglued to the tips of sharpened toothpicks, or wrapped around dowels with double-sided tape. So we've spent about 8 hours cleaning up our parts and getting them ready to accept a coat of paint. Now we're going to take a look at how we clean up the contact points and get them ready for assembly. Every pair or group of mating parts has what is called a correct fit. Now the engineering world has their own definition for this, but for scale modeling, we're going to keep it simple, and we're going to say that the correct fit of a part is determined by where it's located, what it's supposed to do, and how easy it will be to install. Delicate parts should fit without the application of any pressure. By contrast, the landing gear, which will carry the weight of the model, should have a very snug fit. Others, like the seat at the end of the shank on each of the propeller blades, will benefit from a nice square step that will allow the blades to sit at the proper angle. And in all of these cases, the most critical first step is to test fit those parts. Test fitting helps us see immediately whether a part fits correctly or not, and if not, allows us to identify exactly what work needs to be done to make it right. So for test fitting to actually work, it's very important for us to understand what the correct fit of each of the parts is actually supposed to be. And the gun sight provides us with a perfect example of this. We see right away that it's got a significant mold seam, and a quick test fit in the instrument panel indicates that it requires a lot of force to get a good fit. But when we test fit the instrument panel inside the fuselage, we recognize immediately that we're going to have a very fiddly installation. So in this situation, the best fit is going to be an effortless drop-in. So we alternate cleanup and test fitting until we get exactly that. Once the mating surfaces on the detail parts have been cleaned up, using exactly the same techniques we've been looking at to this point, we're going to finish our prep work of the small parts by assembling the drop tanks and the propeller. So before we commit to any cement, the first thing we're going to do is dry fit the parts to make sure everything lines up properly. And we can see right away that we've got a bit of a teeter-totter action going on from tip to tail on this tank. So our plan is to cement the front end of the tank first and allow it to cure completely. Then we can pinch the tail together, cement it, and secure it with some masking tape until it cures completely. As usual, we want to control how much cement we apply. So as we're coming out of the bottle, a quick touch on the lip of the bottle where the shank meets the brush should remove any excess. Assembly of the propeller isn't as difficult as it may appear to be. During the test fitting of the spinner components, a particular orientation produced a better fit. So in order to guarantee the same orientation during the assembly stage, one set of mating components was match marked with a bit of red ink. Then we align all 4 blades on the spinner base. Cement is carefully applied where each shank rests on the face of the spinner base. And finally, we press the shanks into position and align the paddles using the grid on the cutting mat. And with that, all of our detail parts are done, ready for both paint and assembly. So we organize them, protect them, and turn our attention to the big stuff. Getting the correct fit on large structural components of the model, especially those with internal subassemblies. And to demonstrate this, we're going to use the fuselage with the cockpit. As with the smaller parts, the first step is always test fitting our parts. This shows us immediately where corrections need to be made and how much work is required to do them. And from this, we prioritize where we begin our cleanup. The second step is to very carefully complete some of the cleanup work. And the third step is to test fit one more time to confirm that the work that we're doing is giving us the right results. And we complete this simple feedback loop until we get the results that we're looking for. Now let's slow things down and take a closer look so that it makes sense. The correct fit for the fuselage parts includes flush surfaces along the spine and the belly of the model, and all of the panel lines will line up across the joint. So when we test fit the parts, we're looking for anything that will impede our ability to achieve these two things. Removing the locating pins makes it easy to flush up the surfaces, and squaring the step at the base of the tail fillet allows us to align the panel lines. But we're also going to dress the mating surfaces on each part so we get the best possible joint and the maximum contact surface area. As always, to gauge the quality of our work on the contact surfaces, we'll use reflected light, but to gauge the quality of the joint itself, we'll use backlighting. Backlighting is a simple technique where we apply gentle pressure to the joint and then view the joint from the inside out. If we don't see any light coming through that joint, it's a perfect fit. And in about 15 to 20 minutes, the fit of our fuselage parts is excellent. Now we're going to test fit the cockpit to make sure it doesn't foul the fit of the fuselage. So for demonstration purposes, we've added a couple of artificial flaws on the bulkhead itself and on the landing spot for the bulkhead inside the fuselage. And it's best to do this before we've got our cockpit all painted and assembled. Now we trust that the cockpit will fit properly, but when we close up the fuselage halves, we find we've got a large gap right in front of the cockpit. So this tells us we have a problem with the cockpit part. We remove the part, inspect it carefully, and remove a flaw that we find on the bulkhead. Now we trust that everything should fit perfectly. So to verify, we test fit it in the fuselage again. But we still haven't corrected the gap in the fuselage just ahead of the cockpit, which tells us two things. First, the flaw is at the front end of the cockpit part. Second, now we're going to look at the inside of the fuselage part to see if there's a problem there. This time, we find a blemish in the seat for the forward bulkhead, which we remove. Again, we trust that our work has corrected the problem, but we will verify by test fitting. And finally, our work pays off and our fuselage fits beautifully again. But before we can relax, we realize that the instrument panel spans the full width of the inside of the cockpit. So using a little bit of poster gum, we mock up the cockpit and test fit one more time. And to our relief, everything fits beautifully. Now obviously this is an oversimplification, but it does illustrate the process, and the real takeaway here is that we can paint and assemble all of the components for the cockpit with absolute certainty that they will fit correctly. I hope you liked the video. Please like, subscribe, and please do leave a comment, especially if there was something that was missed or if you want more clarification on something. I want to know what you want to know, because that's what fuels this channel. Thank you so much.